So we're going to take a look at something called the triangle angle sum theorem. So simply put, the triangle angle sum theorem states that the three interior or inside angle measurements in a triangle have a sum of 180 degrees. Okay? So you're not going to take my word for this. We're actually going to take a moment and prove this theorem. So we're going to write a little two-column proof here where we're going to have our statements and then our reason. Okay. So the first thing we do with any theorem, with any proof, is we write our given. So the first thing we know is that CD is parallel to AB. And I'm just going to go ahead and put that on my figure as well to help keep track. So we know this because it was given to us. Okay, so what can I do with that? Well, because those are parallel, I know that angle 4 and angle ACD are supplemental, right? So I'm going to go ahead and mark those on here. Angle 4 and angle ACD, this angle right here, they're supplemental. All right, why do I know that? Well, that's the definition of a linear pair. So all I'm doing is logically following from some knowledge that I was given, and then using things that we've already proven to try to come up with something new. Okay, so what else do I know? All right, well, I know that angle 4 and angle, excuse me, that's not quite right. There we go. I know the measurement of angle 4 plus the measurement of angle ACD equals 180 degrees. So you have to be very careful when doing a proof that you're not skipping any steps. So we had to say that they were supplementary first. Now we can say, well, what does that mean? So it means that because they're supplementary, their measurements add up to 180. That's the definition of supplementary. Okay, so now where can we go from there? Okay, well, I know that the measurement of angle 3 plus the measurement of angle 5 equals the measurement of angle ACD. All right, well, why do I know that? That was our angle addition postulate. So I'm saying I can take angle 3 plus angle 5, and I can get that overall big angle ACD. Okay, so let's keep going. Where can I go from here? All right, so eventually I want to somehow be adding 3 angles together, right? Well, right now I know that this measurement of angle ACD can be replaced with these 2 angles right here. So I'm going to do that. I'm going to say, okay, well, the measure of angle 4 plus measure of angle 3 plus the measure of angle 5, those are all going to add up to 180. And I'm allowed to do that because I'm allowed to substitute equivalent things. That's our substitution property of equality, right? Okay. Okay, well, how is that helpful to me? How is that helpful to me? Let's just say measure of angle 3. Okay, well, here's some things that I know. I know that angle 4 is congruent to angle 1 because they're alternate interior angles of this transversal right here. All right? So angle 4 is congruent to angle 1. And I also know that angle 5 is congruent to angle 2 for the same reason, just on a different transversal. So angle 5 is congruent to angle 2. And we know that because they are alternate interior angles. So let's keep going. So if things are congruent, that tells us that their measurements are equal. So let's write that down. That means the measure of angle 4 equals the measure of angle 1. And the measure of angle 5 equals the measure of angle 2. And that's the definition of congruency. Whew, all right, so we're almost done. Well, now I can go about using some substitution, because up here in line 5, I really would like that to be the sum of the interior angles, which means I want angle 1, 2, and 3. So I have angle 3, I need to replace angles 4 and 5. Well, I just gave myself the ability to do that right here. So now I can say, last line, the measurement of angle 1 plus the measurement of angle 3 plus the measurement of angle 2 equals 180 degrees. We're allowed to say that because of the substitution property. Okay, so that is the proof of the triangle angle sum theorem. But what it boils down to is if I add all 3 of the interior angles, I get 180 degrees. So let's see that work in application. So number 1. The way we want to break this down is saying, okay, well, 50 plus 62 plus x needs to equal 180 degrees. And we want to use that to find what x equals. So that means 112 plus x equals 180 degrees, or x equals 68 degrees. So it allows us to find that third degree measurement. And we can do this for a bunch of different triangles, and we can do this for triangles that have expressions for their angles as well as values, right? So here, remember this is just 90, I can say, well, 30 plus 90 plus x plus 2 needs to equal 180. So we just combine like terms just like we did before. X plus 122 equals 180. All right, so that tells me that x equals 58, which means when I go to find this degree measurement, I'm just going to go ahead and plug it in. 58 plus 2 equals 60. So that tells me that that is going to be a 60-degree angle. So just be careful with this one. Don't assume that your value of x is always the value or the degree measurement of the angle, because in this case it is not. Okay, last one. So let's just add all 3 angles together. X plus 20 equals 180. So that means 2x plus 20 equals 180, or 2x equals, subtracting 20 from both sides, 160. Divide both sides by 2, x equals 80, which means both of these would be 80-degree angles. Since they're equal, those 2 angles, they have the same measurement, we also should know that we're dealing with an isosceles triangle. So that's how we're going to prove and apply the triangle angle sum theorem.